The lawnmower.
Yo, what is up guys? I'm William Whitehead and today we're going to be learning about half-lives. First we're going to learn what half-lives are. I'm going to just explain it kind of. A half-life is the required time for something like a really radioactive atom to reduce to half of its initial value so that it's not as unstable. Because an unstable atom is pretty dangerous, which we're also going to be learning about that. And in nuclear physics, it is the time it takes your radioactive atom to decay into a more stable state. It sounds confusing, and it is. I didn't do great on the test. I don't think I did good on anything in it, but I learned a lot about it. So I'm going to teach you about it now. We're going to do a practice problem first to get you a little bit familiar with it. So yeah, we're gonna do one, and it's gonna be really hard, but it's okay because it's supposed to be hard. Yeah. All right. Thallium-208 has a half-life of 3 minutes. How much of a 90-gram sample of thallium-208 has decayed after 20 minutes? First, we have to divide the total time by the half-life, which should be 20 divided by 30, which would be 6.667. Now we must find the remaining mass with it, which is 0.886 grams. I did all this on a calculator, by the way. When we subtract the remaining mass by the initial mass, we get our answer, which is 89.114 grams. So we just divide the half-life by total time, and then we find the remaining mass, and then we subtract that by the initial mass, and then you get your answer. It's pretty cool. This is a little graph I made, and you can see it decaying over time. That's what the atoms do to become less unstable. Why they're a good thing? This really bad thing called Chernobyl happened, where the scientists they messed up, and it's something bad happened because the atoms became too unstable, and they're pretty dangerous when they're unstable, like I said. And yeah, a lot of bad stuff happened, and a lot of people got like cancer and all that sort of thing. It was really bad, but thankfully nowadays we have more safe technology and all that kind of thing, so it should be all good now. Mostly. How to find a half-life. We already did this, but I'm gonna explain it now. On a graph, this is for a graph. Yeah, this is different. On a graph, you can plot the radioactive decay over time, and the time it takes the substance to decay from 100% to 50%. So basically, just half of it is how you find it on the graph. You just go to half. Fun facts about half-lives. The longest known half-life is tellurium-128, which takes 2.2 times 10 to the 24th power to decay, which is 160 trillion times the current age of the universe. That's crazy, guys. A half-life doesn't mean the other half disappears. It just means the atoms split in two and so on, because matter can't be created or destroyed. So it doesn't get destroyed or anything. It just splits in half. And scientific knowledge itself has a half-life. That's crazy. Now we have another practice problem, and it's a pretty easy one. And I'm not going to give you the answer. I'm going to give you a little bit to do it. If you start with 100 grams of a substance with a 1 hour half-life, what will the numbers be? Well, it would be half, so it would be 50, and then 25, and so on. So it's just half. Who discovered half-lives? Ernest Rutherford discovered the term half-life in 1907 when he was working on stuff at his university. Radioactivity. So like atoms and stuff like that. And he found that some materials would take some amount to decay by half, which would be important to his studying with rocks and materials and stuff like that. So he's a pretty smart guy. And that's the end. So now that you know everything about half-lives, you can say you know stuff about half-lives. So thanks for watching, guys. I think my video was pretty cool. I'll see y'all later.